All right, we're just at the end of the chapter review now for chapter 9. I wanted to have a quick word with you about number 30 and 31. They're both marked as triple star questions, but that's a bit ambitious, I think. I don't think they're as hard as they seem. So if you have a look at number 30, it's referring to these three circuit diagrams. This one, very straightforward. This one, I've done a number of examples, and these two resistors are the same size, so that's not going to be difficult. This one here is a little bit tricky because it's got two power sources. So when you've got the two power sources, Kirchhoff's law is you add the voltages together. They're in series, so you're just going to add them. It's not going to be hard at all. So we've got a 6 volt and a 12 volt, so we've got 18 volts. So if you want to redraw the circuit with an 18 volt power supply, then it'll all be straightforward. So not triple starred at all, quite simple. 31. It says figure 8 in your text. Last year's kids have probably crossed that out and changed it to figure 10, which it is. It's figure 10 over here. We've got a graph of two different devices, device A and device B, their resistances, and we have the potential difference graphed against a current. First question asks, are they ohmic? So if you remember, your Ohm's law is, that was a big knuckle, V equals IR. So that means that V is directly proportional to I. If it's directly proportional, when you graph them, you're going to get straight line. So for an ohmic device, you will get a straight line because V is directly proportional to I. So A is ohmic. B is not a straight line, so it's non-ohmic. That's pretty straightforward. B, if they're connected in a series and a current of 200 milliamps passes through them, determine the total potential difference across A and B. So just imagine it. We've got a circuit, we've got A, then we've got B. Okay. The total potential difference. So there's going to be a potential difference across A and a potential difference across B, and the potential difference across the whole thing is going to be A plus B. So at 200 milliamps, we're just going to read it off the graph, and it's even got dots here to tell us. So 2.5 for B and 12.5 for A. That means that the total voltage drop, if you're going across A and B, is going to be 2.5 volts plus 12.5 volts, 15 volts. Again, simple. You just have to understand what's going on in the graph. Question C now. They are in parallel. So again, just imagine it, or better still draw it. In parallel, we've got A and we've got B. So our current is going to split up. Some of it will go through A, some of it will go through B. It wants to know what potential difference it has to be set at so that the current that goes through A is half of the current that goes through B. Now remember, the potential difference is the same when they're in parallel across A and across B. So we want one potential difference value that will give me a current which is half in A the size that it is in B. So it's a matter of looking along the graph axis here, along the potential difference, and finding the spot where the current that you have in A is half the current that you have in B. So if you go up, that's not half of that. Again, not half. When we get up to 15, though, this is 250 and that is 500. So that's the answer, 15 volts. At 15 volts, the current that goes through A will be half the current that goes through B. So the current will split. Calculate for D. Calculate the resistance of device A and compare it with the resistance of device B. Okay, so calculate the resistance of device A at 15 volts. Simple. We've got voltage 15, current to 50 milliamps. Watch out for the milli. So replace the M with by 10 to the negative 3. So it'll be 250 by 10 to the negative 3 amps. And that will allow you to calculate the resistance. So V equals IR, R equals V divided by I. Same thing then with B. Now, I don't know that the person who wrote the question was thinking, they've asked you to compare it as well. So not only have you got to calculate it, but you've got to compare it. And if you're comparing, then you need to say how many times bigger or what percentage one is of the other. So after you've done your calculation, you also need to make that comparison. But they're not difficult, these questions here, I don't think at all. Probably 2-star, maybe not 3. Just understand what's going on in the graph.